Hello everyone, I am Inderpreet Singh from team Cyclone Vision. I will be presenting the proposed solution idea for the problem statement deep learning based cyclone intensity estimation using INSAT-3D infrared imagery. The PS number is SS591. It is a well-known fact that cyclones cause a lot of destruction to property and lives. According to World Meteorological Organization, in the past 50 years, cyclones have caused an average of 43 deaths and $78 million in damages every day. Unlike conventional means, deep learning can help predict the inception of a cyclone before it is formed by looking at the cloud patterns and estimating wind speeds. There has been a need to address the challenge of predicting the formation of cyclones using deep sea analytics. So, me, along with my team, we propose to develop a deep sea model based on a comprehensive literature survey for tropical cyclone intensity estimation and a web app for the visualization of the INSAT-3D IR satellite images. In the rest of the video, I will show you the detailed process of how the web app works, how the deep CNN model will be developed, and everything about our project. So this is how the overall architecture of our proposed solution will look like. First, uh, we will get the original INSAT 3D satellite IR images from INSAT server via APIs. Because these are satellite images, they are going to be very large. So we need to split them into smaller sections first. So as a pre-processing step, for each and every image we receive, we will split them into smaller sections like this. And this way we will be able to localize the wind speed estimates in the region. So instead of getting a wind speed estimate for the entire image at once, we will be getting wind speed estimate for each small section of the image. This will also help us localize potential cyclonic activities in the entire image. And as an added benefit, it will also be easier to use these smaller sections as input for the deep CNN model instead of using the entire image and then downsampling it, uh, uh, losing a lot of information in the process. The wind speed estimates along with the individual sections will then be stitched back to get the entire image in the original satellite form. This way, we will have the entire image along with the sections. The image with the sections will be stored in the database. When the user logs in for the first time, they will see the entire downsample version of the image at once. And once they zoom in, then they will be able to see the high resolution small section of the images that will be loaded on the web portal. This way we will ensure that we also cover the cases of low bandwidth when the user just wants to take a look at the big picture, literally. So this was the main functionality that we have, along with several small functionality that I am now going to explain about. Collectively, all these functionalities will help save precious lives during or even before a cyclone has formed. So this is our shortest route to high elevation slash shelter functionality. Here we are taking elevation data from an open source elevation API. Using this API, we will be able to find any dangerous low-lying beach or low-lying coastal areas that are prone to a cyclone's path or which may be submerged where a user should not be there. Using these APIs, we will be able to find these areas, and then using Google Navigation API, we will show user a path to high elevation or even a cyclone shelter nearby. And we have another functionality, document summarization functionality. Here, because official documents from IMD, NDMA, and even local authorities can be confusing sometimes. So this is an example of how an official alert from IMD looks like. For the layman, it is difficult to interpret. So we will use natural language processing to summarize the entire text of this alert into a more abridged and easy to read form This way, any user will be able to understand what's going on and what needs to be done, what to do, what not to do. And it will be made sure that all these output in the functionality will be in a bullet points form for easy readability. Also, using Google's translation API, it will be provided in a user's preferred regional language as well. We will have another service uh, called alert service. Users can opt in for this service, and they can opt in their own preferred regional language. Again, using Google's translate API, we will make that happen. And using Twilio's bulk SMS and WhatsApp service, we will send official alerts and even the model generator alerts. So for example, let's say the model has predicted 50 knots, 55 knots, and 55 knots here as the wind speed, and there's a potential cyclonic activity here. The model will sound an alert that there people living in these areas need to be careful. The alert service will then send alert from local authorities, IMD, NDMA, and even the model generator alerts via SMS or WhatsApp to users. Because these are SMS and WhatsApp services, these are more accessible than, let's say, a standalone app where the user will have to install the app first and then they will be able to receive notification. Here we are sending them directly if they have opted in. So this was our all the functionalities that we are going to build in this hackathon. Now I will show you the prototype that we have developed for our solution idea. This prototype has been developed in Streamlit framework. This framework is in Python programming language, and it makes it very easy to develop such frameworks. So we have chosen this for our prototype. The final app will be built in Django and React framework, and it will be deployed on AWS cloud. So this is our web visualization functionality. Here the users will be able to visualize the satellite imagery and also the historical images of INSAT-3D IR satellite. They will have a slider that they can use to see historical images like this, and they can also use this button to see the images in sequence. So this will make it easy to visualize the movements of clouds, and anyone can access it. We are not going to have any login functionality, so anyone can see what's going on. And this will be our next functionality, where we will be using the open source elevation API to get elevation of the user. Since we are now using third party open source elevation API, we have limited number of API calls, so we can't just use a lot of these API calls to get all the data around the user. So for now we are just getting the user's location. So you can just click here to get your elevation lat and long, and you can also users can also just type in their location, and it will take them to their location on the map. Also it will show their latitude, longitude, and elevation. Also uh, the bars you see here on this map, these are just for demonstration purposes of how the actual web portal will look like, how this functionality will look like. So in the actual web portal, the users will be able to see, visualize the high and low altitude regions and dangerous places in form of these bars, so that it is very easy to visualize. So for now these are just randomly generated, but eventually the users will be able to use it to find path to safety. And this is the one with the cyclone satellite image wind speed estimation functionality. On the back end we have developed a deep CNN model in PyTorch framework, and the model is ResNet 151. It has been trained on NASA TC, that is Tropical Cyclone Intensity Estimation task. It was a challenge that happened in 2020, and we used that data set for now for the development of our prototype. To show that it is working, we can just uh, see our upload our satellite images. Let's say we upload this, and it is running the inference script right now, and here it is. So the actual wind speed in this satellite image was actually 50 knots, and the wind speed predicted by the model is about 50.28, which is pretty close to what the actual was. So this the model is working as expected, and this is our fourth functionality. Here we have an official document from IMD. As you can see, it's very complex, so we will use text summarization techniques to summarize the entire text of this document into a more easily understandable form. So here we just need to click on summarize button. It will take some time as it is running the BART text summarizer in the background. Here's the summary. So right now the summary looks gibberish and doesn't make much sense, but we will fine tune the BART text summarizer for this specific document. All these official documents have something in common, have some structure. We will try to take advantage of that information to convert all these text into a more easily understandable format. And that's all from our side. Thanks for watching.